Welcome everyone to the European Patent Office presentation of PATINEX 2022. First, I would like to thank the organizers for giving us the opportunity to showcase some of the things we are doing at the European Patent Office. The presentation is called Artificial Intelligence Applied to Classification Use Cases at the EPO. Let's have a look. All of what you see is embedded in our Strategic Plan 2023. There are 5 goals. You see that the program Artificial Intelligence and Blockchain, where the artificial intelligence happens, is hosted in Goal 2, Digital Transformation. For more information, you can have a look at the URL. Today, I am presenting 3 use cases: artificial intelligence-based pre-classification, artificial intelligence-based full classification, and AI-supported reclassification. We have one project, natural language processing, that is creating these services. From prior art, on the left-hand side, here, you see we're training a core language model. And this core language model is then fine-tuned for our specific use cases: pre-classification, classification, and reclassification. In reclassification, the situation is a little bit different, as we are looking only at very few data points. But we will see this later. Let's focus first on pre-classification. How to get the patent application to the correct team. What we're doing with our filings is we have an artificial intelligence component that looks at the unstructured text, the description and claims, and then takes a decision to which out of 1,400 muse ranges, this is a technical category, this filing belongs. And based on the decision of the model, the file is then routed to the correct team. As I've said, we have 1,400 possible ranges to detect in this setting, and we are currently using 800,000 training documents from originally routed documents within the EPO, and this is a sliding window which is updated as new data appears. And we see this in the next slide. Here, you have the MLOps approach and the business KPI. On the left-hand side, the machine learning operation shows how we shortened the deployment times of the internal model. So originally, it took 6 months to deploy a new model, and this time has been shortened now to less than 3 weeks, which allows us to quickly react to changes within the business. The quality of routing on the right-hand side shows you that we managed to reach the business KPI of the correct routing roughly at 90 to 94%. And you also see that there is a slight tendency to increase the metric over time. A particular specificity here is that we only get the feedback on a correct decision later, when the search examiner actually confirms that the file has been correctly routed. This is indicated by these black dots here. So for very recent filings, we don't have a lot of feedback yet. So this means on the one hand side, we have a human quality control built in. This is the feedback from our examiners, but it's a challenge that that feedback only comes later. The system is operational successfully since 1.5 years, and has been used ever since. This is about pre-classification, getting the file to the correct team. Now, let's have a look at full CPC classification. This means we now would like to assign a set of CPC symbols to each and every patent document. The CPC classification currently resides on simple family level, and you're probably aware that the CPC has a high complexity. It's more than 250,000 symbols, and it's a hierarchy that starts at the CPC root node. Then we have sections, we have a class, subclass, main groups, and finally subgroups, with the majority of nodes being subgroup nodes. Now, the data availability becomes less and less as we move down this hierarchy, with some of the subgroups only having 0 or 1 document. And that, of course, poses a challenge to all kinds of supervised machine learning algorithms. To tackle this challenge, we decided to do an aggregation approach. So what we do is we look at each node, and if there are less than 50 documents, we aggregate all sister nodes to the parent until we either reach 50 documents or we reach a main group. This is where the aggregation stops. After the aggregation, we have about 82,000 symbols left. This only reflects 33% of the overall CPC symbol richness. But we will see that this effect is less pronounced in real data. The training for this pipeline is currently done on over 3 million documents, and the test set, the holdout set on which we evaluate the performance of this machine learning component is roughly 800,000 documents. And if we look at these 800,000 documents, we can see that the unique symbol coverage is roughly at 50%, which is still not enough. But the total symbols coverage is at over 90% using our aggregation method. That means if we look at all symbols that are given in 2021 to 800,000 families, we cover 91% of these symbols with our model currently. But we are still working on improving this coverage so that we are reaching 100% in the near future. Now, this bears the question, of course, how good is this model? And this is depicted here on this slide. What you see here is the retrospective performance in classification. You have soft accuracy at 5, which is at 0.8 here, and you have recall at 10, which is at 0.5. So what does that mean? If we look at one specific patent, on average, in 80% of the cases, we find at least one examiner-given symbol in the top 5. At least. We can also find more, but we measure that we find at least one. And that happens in 80% of the cases in the top 5. And recall at 10 means, on average, we find 50% of all given symbols in the top 10. Looking at the complexity of the task, this is quite an achievement. And the data itself is also challenging, which we'll see in the next slide. Here you see some examples of the best predictions. In this case, for Chinese applications, this is the CCI and CCA EPO confirmed symbol. So it describes the invention, CCI, or additional classes, CCA. And you see that our model, in all cases, found the correct classes and also ranked it on the really top ranks. So the green, bold classes are the ones that are in agreement with the examiner-given symbols. Now, let's have a look at the worst cases. We have this here. Again, it's Chinese applications. You have CCI, CCA, EP confirmed symbols in this column here. And then again, you have green symbols on the right-hand side. These symbols do not agree with what has been originally given. However, we went back to the class experts within the EPO and had them have a look at these symbols. And for all the green ones, they confirmed that this is a correct symbol. So while our model might have missed those symbols, it still assigned correct symbols. There is one case where the model made a mistake. These are the red ones here. So those are real mistakes from the model, which is not perfect. And then here you have a series of wrong predictions, but those are based on a data error, because instead of the claims, a wrong phrase has been fed to the model in this case. And this shows how complex it is to evaluate such a model based on the data we have, because there is different truth available. If we have a look at the comparison with the literature, we can see here, this is a publication that I have linked on the top that compares a lot of existing network architectures onto publicly available test sets, MPatent, and USPTO 2 million. And you can see that the precision and the F1 is relatively good for these two test sets. It is IPC subclasses that are tested for. In the case of MPatent, it's 96 classes, and in the case of USPTO 2 million, it's 544 classes. Here you can see the performance of EP-BERT, that is our auto-classification network, for the full CPC, and for the main group model, which we also have. And you can see that our precision and recall values are also quite high, but that the complexity of the symbols, so that the amount of symbols that we are predicting with our models is magnitudes higher. So we're looking at 81,000 CPC symbols in this case, and 8,376 CPC main groups. Also, the test set size is much higher, and the average label count is higher. And this also poses a technical challenge if you want to implement a machine learning system. Yeah, so let's move on. What our classification system can provide. Additionally, it can look at a patent in a paragraph mode. So here you have an example of a patent application from medical technologies. In this paragraph, an X-ray apparatus is explained, and it has been correctly detected by our model to be A61B6 4405. But in the next paragraph of the very same patent, the text is actually about an unmanned aircraft. And also here, the model detected this class, or actually several classes that deal with unmanned aerial vehicles correctly. And this gives a new granularity of how classes can be linked to the text that is ultimately responsible for giving that class. And that is an interesting byproduct, because if you think about artificial intelligence, of course, artificial intelligence can classify an infinite amount of data, while humans have limited time and resources. So on this slide, we actually see how we plan to roll out, in a first step, the automated classification to the examiner. It will be an assisted classification where the AI suggestions, here shown in this red box, appear next to the confirmed symbols that are already there, CPC symbols from other offices, and, if existing, IPC symbols. And then you have the AI suggestions, which our colleagues can either reject or accept, and they can also decide whether it's really at the core of the invention or additional information. This tool has not been rolled out yet, but we're planning to roll it out in the course of the strategic plan 2023. And with this, we are at the final use case, which is reclassification. And this is about reacting to CPC revisions. So often we have the case that a class is not sufficient anymore to describe a technical field, but it has to be split. And this has been a manual process, which is very labor intensive. And here we created a framework that we see on the next slide that helps the examiner to automatically classify documents in a semi-supervised way. So we have an artificial intelligence component. In this case, it's not a pre-trained model, but it's a model that has to be trained every time we are confronted with a new reclassification use case. We have a few training documents that are created by a colleague of ours. And the AI does a batch reclassification and the human does a quality control because, of course, we have ISO standards that need to be fulfilled. So the quality control done by humans is in place here. On acceptance, everything is classified by the artificial intelligence. If the quality is not sufficient, the system rejects the AI classification and a few more training documents need to be added. From a data science perspective, here we provide a framework for a semi-supervised classification task. It's a hierarchical multi-label text classification. The challenge here is different. The challenge is not in the amount of labels or in the sheer amount of data available. The challenge here is the lack of data, because we want to achieve highest classification quality with the fewest example possible. The workload at the EPO for reclassification is about 100 to 200,000 documents per year, which spread across 50 to 100 reclassification projects with a high variability in the actual document numbers. And as I've said before, the goal is to reach really high quality, 90% and plus, while minimizing the manual effort. So again, here is a glimpse of the tool, which is already operational. And with our colleagues, this is a reclassification project that you see here. You can see in this red circle that 18 documents have been used as training examples. And then 796 documents have been automatically classified. And here is an indication of a quality control. One has been carried out and has been accepted. So for roughly 800 documents, an automated classification was carried out, saving, of course, a lot of human effort in this case. Yeah, and with this, we're coming to the end of the presentation. So I walked you through the AI-based pre-classification, which is operational since a year and successfully used in our business to route the incoming patent application to the correct team. We reach a correctness of finding the correct directorate and team higher than 90%, which is a very good result. We have the AI-based full classification, where the model is fully operational and ready to be rolled out to our examiner colleagues. You have also seen that here the recall and precision values are relatively high and that the data situation is complicated. And last but not least, we have the AI-supported reclassification use case, which is a bit different. It's not a use case for deep language models, but for providing the examiner with a framework to quickly set up and train their own models to minimize the manual effort needed for CPC revision reclassification. And with this, I would like to thank you all for your attention. And again, thanks to the organizers for inviting me, and I hope you enjoy the rest of the conference. Thank you.